Our topic of discussion today is some important questions on the convergence and divergence of an infinite series. The theoretical background has already been covered in the previous lecture. So let us now move directly to the important problems based on it. So see the first group of questions based on कंपैरिजन टेस्ट। तो चलिए देखते हैं कंपैरिजन टेस्ट का यूज करके कैसे हम किसी इनफाइनाइट सीरीज को टेस्ट करेंगे कि वो कन्वर्जेंट है या डाइवर्जेंट है। कंपैरिजन टेस्ट दो तरह के होते हैं, एक तो डायरेक्ट कंपैरिजन टेस्ट और दूसरा लिमिट कंपैरिजन टेस्ट। So what is direct comparison test? Suppose there are two infinite series, sigma un and sigma vn, such that un is less than equal to vn. Then if sigma vn is convergent, then sigma un is also convergent. And second point, if sigma un is divergent, then sigma vn is also divergent. ठीक है, यह है डायरेक्ट कंपैरिजन टेस्ट। और सेकंड इज लिमिट कंपैरिजन टेस्ट। लिमिट कंपैरिजन टेस्ट लिमिट कंपैरिजन टेस्ट ये लिमिट कंपैरिजन टेस्ट क्या है? इसमें हम क्या करेंगे, सपोज सिग्मा यूएन एंड सिग्मा वीएन are two infinite series such that limit n tends to infinity un by vn is a finite value, finite and non-zero means non-zero finite. Then sigma un and sigma vn both are convergent or divergent together. It means, what does it mean? It means अगर मान लो कि सिग्मा यूएन और सिग्मा वीएन दो इनफाइनाइट सीरीज है, इस तरह कि हमने लिमिट निकाला n टेंड्स टू इंफिनिटी ऑफ un by vn and this limit is equal to a finite value non-zero, तब सिग्मा un एंड सिग्मा vn या तो दोनों कन्वर्ज करेगा या फिर दोनों डाइवर्ज करेगा एक साथ। कन्वर्ज करेगा तो दोनों और डाइवर्ज करेगा तो दोनों एक साथ। तो इसमें हम क्या करते हैं, यहां पे सिग्मा वीएन हम इस तरह से एज्यूम करते हैं कि यूएन में वीएन से डिवाइड करके, और अगर हम लिमिट एन टेंस टू इन्फिनिटी अगर इस पर हम अप्लाई करते हैं तो वो कोई ना कोई एक फाइनाइट वैल्यू आना चाहिए। अगर ऐसा आता है तो सिग्मा वीएन के बेस पे हम सिग्मा यूएन के नेचर को बता सकते हैं। इफ सिग्मा वीएन इज कन्वर्जेंट देन सिग्मा यूएन इज ऑल्सो कन्वर्जेंट। इफ सिग्मा वीएन इज डाइवर्जेंट देन सिग्मा यूएन इज ऑल्सो डाइवर्जेंट। दिस इज लिमिट कंपैरिजन टेस्ट। सो आइए देखते हैं एक एक करके इस ग्रुप ऑफ क्वेश्चंस को, इस ग्रुप ऑफ इनफाइनाइट सीरीज को एक एक करके टेस्ट करके देखते हैं ये कन्वर्जेंट है या डाइवर्जेंट। सो द फर्स्ट series is sigma n equal to 1 up to infinity square root of n divided by n square plus 1. Sigma n equal to 1 up to infinity square root of n divided by n square plus 1. Here un is equal to square root of n divided by n square plus 1, which can be written as n power 1 by 2 divided by n square taken as common. This is 1 plus 1 by n square. This is equal to 1 divided by n power 3 by 2 into 1 plus 1 by n square. Cancelling the numerator and denominator by n power 1 by 2. This is the result. Now, see here. If we divide this expression by 1 by n power 3 by 2, we can find easily the finite limit. So, let us suppose Vn is equal to 1 divided by n power 3 by 2. Okay? We have un divided by Vn equal to, if we divide this expression by this expression, the result will be 1 divided by 1 plus 1 by n square. And so, limit n tends to infinity, un by Vn is equal to only 1, because if we apply the limit, 1 by n square becomes 0. So 1 plus 0 is 1 and 1 divided by 1 is 1. So this is the value. This is the finite limit and non-zero. It means sigma un, it means sigma un and sigma vn both are either convergent or divergent. Now, let us check whether sigma vn is divergent or convergent. So, sigma vn is equal to sigma 1 by n power 3 by 2 is a P series with P equal to 3 by 2, which is greater than 1. And we know very well the P series, सबको मालूम है, sigma 1 by n power P. This is P series. Every infinite series in this form is called P series. So this series is convergent for P greater than 1 and divergent for P less than equal to 1. This should be kept in mind always. So see here P is equal to 3 by 2, which is greater than 1. So sigma Vn is convergent by P series. And so by comparison test, we have already seen here sigma un and sigma vn both are either convergent or divergent. So here sigma vn is convergent. So sigma un is also convergent. Sigma un is also convergent. This is the use of comparison test. This is limit comparison test. Okay. Next question is sigma n equal to 1 up to infinity sine 1 by n. sigma n equal to 1 up to infinitive sine 1 by n. Here un is equal to sine 1 by n. So if we take Vn equal to 1 by n, we have un by Vn equal to sine 1 by n divided by 1 by n. Okay. So for 1 by n equal to x, we have un by Vn is equal to sin x by x. Now, limit n tends to infinitive, un by Vn is equal to limit x tends to 0. See here, if n tends to infinitive, 1 by n tends to 0, and so x tends to 0. So this is limit x tends to 0, and in place of un by Vn, now it is sin x by x. We know very well this is equal to 1. And this is non-zero finite. So sigma un and sigma Vn both are either convergent or divergent. Okay. Now, sigma Vn is equal to sigma 1 by n is a P series with P equal to 1. So sigma Vn is divergent by P series divergent. So by limit comparison test, we have sigma un is equal to sigma sine 1 by n is also divergent. Okay, very easy. The next question is n plus 1 power 1 by 3 minus n power 1 by 3. Sigma n plus 1 power 1 by 3 minus n power 1 by 3. We have to test this series. Here, un is equal to n plus 1 power 1 by 3 minus n power 1 by 3. We can write it taking n power 1 by 3 as common here. We have n power 1 by 3 into 1 plus 1 by n power 1 by 3 minus n power 1 by 3. Now, we can expand it using binomial theorem. We have n power 1 by 3 into 1 plus. We know very well that 1 plus x power n is equal to 1 plus nx plus n into n minus 1 by factorial to x square plus dot dot. Using the same formula, same theorem here, in place of x, this is 1 by n, and in place of n is 1 by 3. So nx means 1 by 3n plus higher order terms minus n power 1 by 3. This is equal to, now multiplying every term in this bracket by n power 1 by 3, we have n power 1 by 3 plus 1 by 3 into n power 1 minus 1 by 3 is 2 by 3 plus dot dot minus n power 1 by 3. This is equal to subtracting n power 1 by 3. We have 1 by 3 into n power 2 by 3. If we suppose Vn equal to 1 by n power 2 by 3, then Un by Vn is equal to Un is this and Vn is this. So dividing this expression by this expression, we have 1 by 3. So limit n tends to infinity, Un by Vn is equal to 1 by 3, which is non-zero finite value. So sigma Un and sigma Vn both are either convergent or divergent. Now, sigma Vn is equal to 1 by now sigma Vn is equal to sigma 1 by n power 2 by 3 is a P series. P series with P equal to 2 by 3, which is less than 1. You know very well that in P series, if P is less than equal to 1, then the series is divergent. So, sigma Vn is divergent here. And so by limit comparison test, sigma Un is also divergent. Okay, clear, very easy. Now, the next series is 1 by 3 power p plus 1 by 5 power p plus 1 by 7 power p plus dot dot. Here, Un is equal to 1 divided by, see here, this is 2 into 1 plus 1. This is 2 into 2 plus 1. This is 2 into 3 plus 1. So this is 2n plus 1, 2 into n plus 1 power p. Means this is sigma Un, which is sigma 1 by 2n plus 1 power p. So Un is equal to 1 by 2n plus 1 power p can be written as 1 by n power p as common. If we take n power p as common, it is left with 2 plus 1 by n power p. Now see here, this is 1 by n power p. So if we divide this expression by 1 by n power p, we can find the finite limit easily. So let Vn is equal to 1 by n power p. So Un by Vn is equal to, dividing this expression by 1 by n power p, we are left with 1 by 2 plus 1 by n power p. Okay. So limit n tends to infinity, Un by Vn is equal to, what will be left? Limit n tends to infinity, 1 by n equal to 0. So 2 plus 0 is 2. So 2 power p. This is equal to 1 by 2 power p. And 1 by 2 power p is not equal to 0 for any value of p. Okay. So sigma un and sigma vn both are either convergent or divergent. Now, sigma vn is equal to sigma 1 by n power p, n power p. We have supposed here vn equal to 1 by n power p. Sigma vn is sigma 1 by n power p is a p series whose value has not been given here, but it is p series. It means sigma vn is convergent for p greater than 1 and divergent for p less than equal to 1. So sigma un is also convergent or divergent when p is greater than 1 or p is less than equal to 1 respectively. Means the convergence and divergence of sigma un depends upon the value of p. If p is greater than 1, then sigma un is convergent. If p is less than equal to 1, then sigma un is divergent. Okay? The next is 1 power 4 by 1 power 3 plus 2 power 4 by 2 power 3 plus 2 power 3 power 4 by 3 power 3 plus dot dot. This is equal to sigma un, where un is equal to n power n plus 1 divided by n power n, means this is equal to n. So sigma un is equal to sigma n. This is equal to 1 plus 2 plus 3 plus 4 plus dot dot dot, which is by default convergent, divergent. By default divergent. No need to apply any comparison tests here. Since if you continue adding 1, 2, 3, 4, 5, 6, 7, the sum is not finite, and that's why the next series is 1 by a into 1 square plus b plus 1 by a into 2 square plus b plus 1 by a into 3 square plus b plus dot dot. This is equal to sigma un, where un is equal to 1 by c here. A and b are fixed. And here it is 1 square, here it is 2 square, here it is 3 square and 4 square, dot dot dot. So this is a into n square plus b. This is the general term. We can write it 1 by n square as common. This is a plus b by n square. So, if we divide this expression by 1 by n square, we can find the finite limit easily. So, let Vn is equal to 1 by n square. We have un by vn is equal to, dividing this expression by this, we are left with, the result is 1 by a plus b by n square. So limit n tends to infinity, un by vn is equal to limit n tends to infinity 1 by a plus b by n square. This is equal to, if we apply the limit, here b by n square becomes 0. So a plus 0 is a. So 1 by a is 1 by a. For a fixed value a, which is non-zero finite. So sigma un and sigma vn, either both are convergent or divergent. So now sigma vn is equal to, sigma vn is this. We have supposed here vn equal to 1 by n square. So sigma vn is sigma 1 by n square is a p series with p equal to 2, which is greater than 1. So sigma vn is convergent, and so by limit comparison test, sigma un is also convergent. Now, the next group of questions are based on D'Alembert's ratio test. So let us test the infinite series whether this is convergent or divergent by D'Alembert's ratio test. Let us see first what is D'Alembert's ratio test. In D'Alembert's ratio test, first of all, we identify an, suppose, the general term of the infinite series, and an plus 1. And then we find limit n tends to infinity an divided by an plus 1. Suppose this is equal to L. Now, if L is greater than 1, then sigma n is convergent. If L is less than 1, then sigma n is divergent. And if L equal to 1, this test fails here. Means this test is not applicable. We will apply some another test. So first series is factorial 2 by 3 plus factorial 3 by 3 square plus factorial 4 by 3 power 3 plus dot dot. This is sigma n, where an is equal to factorial n plus 1 divided by 3 power n, because the numerators are factorial 2, factorial 3, factorial 4, means factorial 1 plus 1, factorial 2 plus 1, factorial 3 plus 1, in this way. So the numerators in the nth term, numerator will be factorial n plus 1. And the denominators are 3 power 1, 3 power 2, 3 power 3, means 3 power n. In the nth term, this is 3 power n. So an plus 1 is equal to factorial n plus 2 divided by 3 power n plus 1. So an divided by an plus 1 will be equal to factorial n plus 1 divided by 3 power n divided by factorial n plus 2 divided by 3 power n plus 1. This is equal to factorial n plus 1 divided by 3 power n into 3 power n plus 2 divided by 3 power n plus 1 divided by factorial n plus 2. This is equal to cancelling the factorials. It is n plus 2 and cancelling here. This is 3. So the result is 3 divided by n plus 2. So limit n tends to infinity, an divided by an plus 1 is equal to 0 and 0 is less than 1. So the series sigma un is divergent. Now the next question is 1 by 3 square plus 1 into 2 by 3 into 5 whole square plus 1 into 2 into 3 by 3 into 5 into 7 whole square plus dot dot dot. This is equal to sigma n, where an is equal to an equal to 1 into 2 into 3 into dot dot n by 3 into 5 into 7 into dot dot. This is 3 means 2n plus 1. So up to 2n plus 2 into 2 plus 1 up to 2 into 3 plus 1. So in this way, this is up to 2n plus 1. Product up to 2n plus 1 whole square. This is equal to factorial n divided by 3 into 5 into 7 dot dot 2n plus 1 whole square. So an plus 1 is equal to factorial n plus 1 divided by 3 into 5 into 7 dot dot 2n plus 1 into 2n plus 3 whole power 2. It means an divided by an plus 1 is equal to factorial n divided by factorial n plus 1 whole square multiplied by 3 into 5 into 7 into dot dot into 2n plus 1 into 2n plus 3 divided by 3 into 5 into 7 dot dot 2n plus 1 whole square. We can cancel here factorial n and factorial n plus 1 by n plus 1 times, and all the factors up to 2n plus 1 cancel. We are left with 1 by n plus 1 whole square into 2n plus 3 by 1 whole square. This is equal to 2n plus 3 divided by n plus 1 whole square. We can write it n square as common. So 2 plus 3 by n whole square divided by n square as common. So 1 plus 1 by n whole square. N square cancel. This is equal to 2 plus 3 by n divided by 1 plus 1 by n whole square. So limit n tends to infinity, a n divided by a n plus 1 is equal to, if we apply the limit here, 3 by n becomes 0 and 1 by n becomes 0. So 2 plus 0 is 2, 1 plus 0 is 1, 2 by 1. 2 by 1 whole square is 4 and 4 is greater than 1. So sigma n is convergent. Okay, very easy. The next question is 2 by 1 plus 2 into 5 by 1 into 5 plus 2 into 5 into 8 by 1 into 5 into 9 plus 2 into 5 into 8 into 11 divided by 1 into 5 into 9 into 13 plus dot dot. This is equal to sigma n, where an equal to 2 into 5 into 8 into 11 dot 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 3n minus 1. The pattern is 3n minus 1. 3 into 1 minus 1 is 2. 3 into 2 minus 1 is 5. 3 into 3 minus 1 is 8. 3 into 4 minus 1 is 11. So this is 3n minus 1. And in the denominator, this is 4n minus 3. 1 is 4 into 1 minus 3. This is 4 into 2 minus 3. This is 4 into 3 minus 3. In the same way, 4 into 4 minus 3. So this is the general term. Okay. So an plus 1 is equal to 2 into 5 into 8 into 11 dot dot 3n minus 1 into, in place of n it is n plus 1. So 3n plus 3 minus 1 is 3n plus 2 divided by 1 into 5 into 9 into 13 dot dot 4n minus 3. And this is 4n plus 1 up to 4n plus. So an divided by an plus 1 is equal to, if we divide this expression by this expression, the result is 4n plus 1 divided by 3n plus 2. This is equal to n taken as common, which is 4 plus 1 by n divided by n taken as common, this is 3 plus 2 by n. This is equal to 4 plus 1 by n divided by 3 plus 2 by n. So limit n tends to infinity, an by an plus 1 is equal to 4 by 3, which is greater than 1. So sigma n is convergent by real numbers ratio test. Very easy. The next question is sigma n equal to 1 up to infinity x power n minus 1 divided by n multiplied by 3 power n. X power n minus 1. sigma n equal to 1 up to infinitive x power n minus 1 divided by n multiplied by 3 power n. Okay, this is equal to sigma an, where an is equal to x power n minus 1 divided by n multiplied by 3 power n. So an plus 1 is equal to x power n divided by n plus 1 multiplied by 3 power n plus 1. So an divided by an plus 1 is equal to x power n minus 1 divided by n into the power n multiplied by n plus 1 multiplied by 3 power n plus 1 divided by x power n. This is equal to, this cancels this by x, and this is left with n plus 1 divided by n multiplied by 3 power n cancels this by 3. So this is 3 by x. Okay. This can be written as 1 plus 1 by n multiplied by 3 by x. So limit n tends to infinitive, an divided by an plus 1 is equal to 3 by x. Now, sigma an is convergent for 3 by x greater than 1 or 3 greater than x or x less than 3. Sigma an is divergent for 3 by x less than 1 or 3 less than x or x greater than 3. But for 3 by x equal to 1 or 3 equal to x, this test fails. Okay, so if we have to use D'Alembert's ratio test, so by D'Alembert's ratio test, this series is convergent for x less than 3, and this series is divergent for x greater than 3, but for x equal to 3, this test fails. We can use some another test to test the convergence of this series. Okay. Next is square root of n divided by square root of n square plus 1 x power n. An plus 1 is equal to square root of n plus 1 divided by square root of n square square root of n plus 1 whole square plus 1 x power n plus 1. This is equal to square root of n plus 1 divided by n square plus 2n plus 1 plus 1, 2. X power n plus 1. So, an divided by an plus 1 is equal to square root of n plus 1 divided by n square plus 1 divided by square root of n plus 1 divided by n square plus 2n plus 2, and it is x power n plus 1, x power n divided by x power n plus 1. This is equal to, this is a square root of n plus 1, a square root of n plus 1, n plus 1 cancel. This is n square plus 2n plus 2 divided by n square plus 1, and it is 1 by x. This is equal to, taking n square as common, so n as common out of the square root, this is left with 1 plus 2 by n plus 1, 2 by n square divided by 1 plus 1 by n square, 1 by x. So limit n tends to infinity, an by an plus 1 is equal to, this is equal to 1 by x. So sigma an converges for 1 by x greater than 1, or 1 greater than x, or x less than 1. Sigma n diverges for 1 by x less than 1, or 1 less than x, or x greater than 1. For x equal to 1, this test fails here. Next question is 1 by 2 root 1 plus x square by 3 root 2 plus x power 4 by 4 root 3, and so on. This is equal to sigma an, where an is equal to x power 2n minus 2 divided by n plus 1 square root of n. Okay. So an plus 1 is equal to x power 2n divided by n plus 2 multiplied by square root of n plus 1. So an divided by an plus 1 is equal to x power 2n minus 2 divided by n plus 1 multiplied by square root of n multiplied by n plus 2 square root of n plus 1 divided by x power 2n is equal to 1 by x square multiplied by n plus 2 divided by n plus 1 into a square root of n plus 1 divided by a square root of n. This is equal to 1 by x square multiplied by n into 1 plus 1 by n, 2 by n, divided by n into 1 plus 1 by n into a square root of 1 plus 1 by n. So, limit n tends to infinity, an by an plus 1 is equal to, this becomes 1 plus 0 is 1, and this is 1 plus 0, this is 1 plus 0, so all 1. So 1 multiplied by x, 1 by x square equal to 1 by x square. So sigma an is convergent for 1 by x square greater than 1 or 1 greater than x square or x square less than 1, and sigma n is divergent for 1 by x square less than 1 or 1 less than x square or x square greater than 1, and this test fails here for x square equal to 1. Okay, you can find the conclusion here. The next one, on the basis of D'Alembert's ratio test, is factorial n to power n divided by n power n. Factorial n to power n divided by n power n. N equal to 1 up to infinity. Factorial n to power n divided by n power n. Okay. This is equal to sigma an, where an is equal to factorial n to power n divided by n power n. So an plus 1 is equal to factorial n plus 1 to power n plus 1 divided by n plus 1 power n plus 1. This can be, okay. So an divided by an plus 1 is equal to factorial n to power n divided by n power n multiplied by n plus 1 power n plus 1 divided by factorial n plus 1 to power n plus 1. This is equal to factorial n divided by factorial n plus 1. Then 2 power n divided by 2 power n plus 1. and n plus 1 divided by n power n multiplied by n plus 1. This cancels this factorial by n plus 1 times, and n plus 1 cancels n plus 1 here. This cancels this by 2 times. So this is equal to 1 by 2 multiplied by 1 plus 1 by n power n. Okay. So limit n tends to infinity, an by an plus 1 is equal to 1 by 2 multiplied by. This limit is equal to e. So this is equal to e by 2, which is greater than 1. Okay. So sigma n is convergent. Okay. Very easy.